We're going to turn to our second speaker, Orville Schell. Let me say a few words about Orville. Many of you know him from his days at Berkeley. Orville is the Arthur Ross Director of the Center on U.S.-China Relations at the Asia Society in New York. He's a former professor and dean at the UC Berkeley School of Journalism. He was born in New York City, graduated magna cum laude from Harvard in Far Eastern History, was an exchange student at National Taiwan University in the 1960s, and earned his doctorate at UC Berkeley in Chinese history. He worked for the Ford Foundation in Indonesia, covered the war in Indochina as a journalist, and has traveled widely in China since the mid-70s. And it's a real pleasure to introduce Orville Schell.
Well, thank you, John. It's a pleasure to be back here at Berkeley, and all the more so to be here with Ma-Yun, who's an old friend, and who, for those of you who may not know too much about him, has been for a long time really on the cutting edge of this very interesting, expanding world of civil society that's been in a state of tension with the government, but sometimes a constructive tension. And as you can see, there's much to be done in that country in terms of environmental cleanup. You know, I landed today, I flew in from China this morning, and when I left, it was one of those days when you could hardly see the end of your nose. You've all been reading about the air pollution, and it is very disturbing. One aspect of the whole mosaic of problems that have extended from China's very dynamic development. But actually, it's not something that worries me quite as much as the whole question of carbon emissions. You may wonder, how can I say that? And looking at what Ma-Yun confronts every day in water pollution, breathing the air, everybody's wearing masks now. There's a huge run in cities of North China and elsewhere that are polluted on air purifiers, air filters for cars, for apartments, which of course just makes more pollution. But how could one say that they're not particularly worried about it? Well, for the following reason. The truth is, we know how to clean these things up. I grew up in New York. As a kid, every morning you'd wake up, there'd be a layer of grit, of soot on the windowsill, because we burned coal. London was one of the most suffocating cities of the world as a result of the Industrial Revolution and burning coal. Los Angeles, you remember Los Angeles? Used to have horrendous air pollution from automobiles. So it is within the scientific ability of the world to clean up these kinds of conventional pollutants. And I do believe that China, because it has a rather extraordinary organizational capacity, and it recognizes now this is a challenge of monumental proportions, will do that. What worries me infinitely more is something I want to share a few thoughts with you about now, and that is the rather horrific prospect of increased carbon emissions and the way in which that leads to climate change, and how in a very fragile environment like China, where there's a quarter of the world's population on 7% of the arable land, it's a very delicate balance. And one area that I want to just speak to you about, really almost metaphorically, is this vast area that, called the Tibetan Plateau. Now, it used to be, this was an area of great mystery, enchantment. Why? Because it was hard to get there. Nobody wanted you to go there. But it was what the Brits used to call a blank place on the map. It was a place that excited the imagination of explorers because it was so remote and so few people lived there. Lhasa, the great mystical city that begged so many people to try to reach it. It now turns out, in its modern guise, that the Tibetan Plateau is a place of incomparable importance. Why? Because if you look at any of the maps you've been seeing, and Madryn showed many, every major river system of Asia finds its headwaters in this very remote region that begins above Afghanistan, the Hindu Kush, this majestic range of mountains that arcs around sort of above Pakistan, India, the Karakoram range, heads into the Himalaya range, which then bends upward back of Yunnan province and Sichuan province, the Hongguan range, and other mountains that head north. And it is behind that great rim of the 14 tallest peaks in the world that the Tibetan Plateau, which is bigger than all of Europe, lies. And one of the sources of the water for the rivers which come down, the Amudarya, the Indus, the Ganges, the Brahmaputra, the Salween, the Irrawaddy, the Mekong, the Yangtze, the Yellow River. I mean, just think about it. That is one hell of a network of rivers. And they all begin in this very strange, remote piece of real estate at the top of the world, what was known as the roof of the world. Now, what makes those rivers behave in significant measure as they have behaved for centuries and centuries and centuries are the ice systems, the glaciers, that are within this great arc of mountains. And what those glaciers have done traditionally is to serve as reservoirs. They freeze water. Snow falls, it gets compacted into ice, and it sits there sometimes for millennia before it gets released. But it gets released into these various river systems at critical times, before and after the monsoon. So it isn't that a very preponderant proportion or percentage of the flow of all of these rivers comes from glaciers, but a very important part seasonally, what they call shoulder seasons, when monsoons have stopped or monsoons haven't started. It kind of evens the flow out. And all of the major civilizations of Asia have grown up over the last few millennia around these rivers. And in the case of the Yellow River, it flows out across from Qinghai province to the back of the Tibetan Plateau, down through Ningxia province, down through some very arid regions to the North China Plain. And as you probably know, China's sort of divided into two very stark geographic areas. One is the very dry, arid north, where wheat is grown. And the other is the very wet south of the Yangtze, where rice is grown. And the Yellow River is the reason why North China really has existed. It's the reason why great dynasties like the Tang Dynasty, the Sung Dynasty, many other dynasties could survive and flourish because of the Yellow River. And you see it. It's this giant sort of serpentine flow of muddy brown water that flows across near desert in much of its upper reaches, and then down across the North China Plain and finally out into the ocean. And in the last several decades, there have been numerous years where it ceases to flow altogether at its lower reaches, because so much water is extracted upstream, and much of the water, of course, is also quite polluted. Now, how does this figure all into the whole climate change equation? Well, many things have happened that you know about. Their precipitation patterns have changed, particularly on the North China Plain. Groundwater has sunk, which has made rivers even more important. But there are some other things that have happened up on the Tibetan Plateau itself, which are extremely worrisome. And since I actually left Berkeley, we have a project, the Asia Society in New York, and I've worked with this wonderful, interesting and intrepid mountain climber. And I'll show you a little short video at the end of some of his work to try to map these glaciers and what's happening to them. So what is happening to them? One thing that we discover is that at very high altitudes, the elevation of temperatures caused by heat trapping gases is much more accelerated than at lower altitudes. And this is very complicated that some of you in the sciences will know better than I. We could get into it maybe in question and answer period. But this means that whatever happens down below, and you may hear an average of a temperature rise around the world of 1%, below 1%, whatever it may be, up there, it's a lot higher because you're getting an average of the extremes at both ends. So the first thing that this triggers, of course, is an increased rate of melt of these glaciers. It also means that because the air is warmer, less snow falls. So what used to fall as snow to accumulate on the glaciers and to be trapped in these sort of frozen reservoirs runs off. And it throws the whole balance. There's a thing amongst glaciologists called equilibrium, where the zone, the accumulation zone at the top of the glacier accumulates a certain amount, and the ablation zone at the bottom, where the glacier calves off and sends big sort of chunks of ice rolling down the mountains or melting. This is all thrown out of whack. So the glacier not only begins to melt and become shorter, but it ceases to be able to regenerate and to accumulate. Another very interesting thing is happening, which is even sort of more, I think, worrisome. There's been some very interesting scientific work done, particularly down at the University of California at San Diego, on what's called, atmospheric brown clouds. And what these are, particularly over the Indian subcontinent, are great clouds of pollution that are generated by particulate matter, among other things, that come from the burning of coal, come from diesel engines. And any of you who've been in India on the highway, you know what it is to travel behind any vehicle that's spewing great toxic clouds of black diesel, exhaust out the back. And these go up in the air, and they have two very complicated effects. One, the black carbon absorbs heat. But there are other particulate matter particles in suspension, in this sort of aerosol suspension, that reflect heat. Nitrates, sulfates, things of that nature. They're like little mirrors. And in fact, people, in speaking about sort of engineering fixes for climate change, often ponder spraying the atmosphere with certain kinds of sulfur particles to reflect heat back out. But these ultimately fall back down to Earth. The particulate matter, I'll tell you its odyssey in a moment, but the strange effect of these atmospheric black clouds is both in a certain way to heat up certain levels of the atmosphere, but also to mask degrees of global warming that would already have happened if the reflective capacity of these clouds wasn't at work. So the climate has been forced, but if the atmospheric brown clouds ever get cleaned up, which they should, because they're tremendous health risks, there will be a sudden jump in the elevation of temperatures because you'll lose that reflective capacity. So there's a kind of a push and a pull going on here. The other thing that happens is when the monsoon sweeps across the Indian subcontinent, it takes up this particulate matter into the Himalaya ice fields, and it deposits it on the glaciers. And because more of that moisture is now falling as rain, it means that it is settling on top of glaciers. It never gets buried by a clean level of snow, a clean layer of snow. And it means that it is building up a kind of a darker surface on these glaciers that acts like a solar collector, increasing the melt rate of the glaciers, diminishing its ablato effect, its ability to radiate heat back out into space. So this is another reason why the glaciers are sort of under threat. And who would have ever thought that these incredible sort of Moby Dicks of the the geological world that seems so massive and so invincible would ever come under the threat from anthropogenic changes such as climate change. But there you have it. So this very fragile, once rather forgotten area suddenly assumes an enormous importance to all of Asia. And we've talked about many things here today, but one that certainly can't be ignored is, of course, food security. And the threat about people being displaced because rivers cease to act as they've always acted in the past. And countries going to war. One of the things that the world does not yet have in any significant measure is transnational agencies capable of adjudicating what happens in these rivers. And now China is building scores of dams, not only throughout Tibet, these rivers that flow down to Pakistan, India, Burma, and elsewhere, but also on the Mekong, because that's in China before it goes down through Southeast Asia. So there are all sorts of threats to stable, reliable water supplies that grow out of the really unknown effects yet to be charted of climate change. And this creates a tremendous sense of anxiety for all of these countries, which are downstream from the sort of catchment area, which is, in some sense, the frozen reservoirs of the Tibetan Plateau. So this, in a sense, as I suggested at the beginning, is kind of a metaphor for a very delicately calibrated system that we never really even thought about. It just did its thing. And civilizations adjusted to it. And populations adjusted to it. And now, if it gets thrown out of kilter, we could have a tremendous amount of social dislocation. And even, I think, the possibility of countries going to war over water. Because there really is nothing more important. There's nothing you can't replace water with something else as you can replace oil with sun, wind, tide, whatever else. There's no alternative. And particularly as more and more water becomes polluted, this relatively pure water that's flowing down from this very remote region in the Tibetan Plateau is more precious than ever. And you begin to see within China itself now projects to remedy the imbalances that are being created by growing populations, diminished rainfall, and other aberrant kinds of weather pattern changes. We have a thing called the Nanshui Beidiao, the South-North Water Transfer Project, which Majun had a little map on it. You may have missed it. It basically is as if you decided you were going to replumb your house. China is replumbing itself by hooking up the Yangtze River with the Yellow River in North China in what is the largest engineering project ever executed by mankind. And there are originally 3 channels planned. They finished one along the old Grand Canal. There's another one that's come a little to the north. And this is to bring water to the parched north. The big cities like Beijing, Tianjin, many, many others that are sucking groundwater out at an alarming rate. And they're not able to replenish surface supplies because there isn't adequate rainfall. And rainfall patterns have also changed. So we get a whole series of attendant knock-on effects that happen when climate adjusts just a little bit. And when things like the reservoirs of Asia, the frozen reservoirs of Asia, get perturbed by climate change. Now, let's just, I think I'll stop here. It's kind of a very quick thumbnail sketch of one problem that's intimately related to climate change. One other very alarming aspect to this whole proposition on the Tibetan Plateau is, of course, as temperatures are elevated, permafrost thaws. And permafrost has frozen the grasslands of the Qinghai province sort of area and higher elevations in Tibet, so that they haven't been able to biodigest the organic matter in the soil and release methane. And as you all know, methane is some 20 times more harmful as a heat trapping gas even than carbon. And now, with the elevated temperatures, permafrost is melting, and the pastures are drying out, and this biodigestion is going on, and methane is being released. This is almost even more worrisome a source of greenhouse gas than even industrial emissions. Now, I don't want to depress you too much. Let me leave you. These are beautiful mountains. It's a magnificent landscape, and we have done a lot of work up there and have a whole exhibit of photographs that we've taken around the world. And I want to show you just one quick little few-minute video of this mountain climber that I've worked with, made several films with, that we've been doing this project. We call it Coal Plus Ice, which really charts the carbon arc from the coal mine to the factory, to the atmosphere, to the mountains, elevated temperatures, glaciers, rivers, and then, of course, ultimately back into the ground. And we have this magnificent photographer who does pictures of hurricane waves off New York, because it all comes home to roost somewhere, somehow, for everyone. And in New York's case, the increased instances of very aberrant extreme weather. So let's just look at this.
2007, I was approached by Marty Smith, a producer at Frontline, making a 2-hour program called Heat, on the business of global warming. And he wanted images of melting glaciers in the Himalayas. I knew of a picture Mallory had taken of the north side of Everest in 1921. Beautiful, iconic photo. It makes this fantastic S-turn right up to the accumulation zone at the base of the north face of Everest. I was interested in that photo for 2 reasons. First, I knew how to get there. Second, it was a photograph taken by George Mallory, the famous mountaineer who coined the phrase, "because it's there." He was on 3 expeditions to Everest, 1921, 22, and he died high on Everest in 1924 with his companion Andrew Irvin. So Marty and I went up to Rongbuk Monastery at the base of Everest, and he sent me off up the mountain with my Pentax camera and 2 monks as my porters. And we found Mallory's photo point. Right away, we knew these glaciers had melted a lot. There in front of me, I was holding Mallory's photo in black and white from 1921. I could immediately see the results. In fact, the glacier we were looking at, the main Rongbuk Glacier, had already melted 300 or 400 feet vertically in the span of 88 years. And if that glacier hadn't shown such extreme and accelerating melt rate, the project, for me, probably would have ended there.
Well, that just gives you a little taste. So thank you so much.
Thank you.